Hi, I'm John Calder of Acoustic Geometry. Let's talk about acoustics, which is basically how sound works in rooms. It may seem complicated, so let's make it simpler. Most rooms have flat walls and flat ceilings, and sound bounces off of these. So how does that affect the sound? I'll use these two Nerf guns to demonstrate. I've got this one aimed so this disc goes directly to the ear. That represents direct sound. I've got this one aimed so that disc bounces off the wall and it represents reflected sound. I'll shoot them both at the same time. Reflected sound arrives at our ears later than direct sound, even though it started out at the same time, because it's traveling farther. And this wall is only one flat surface. There are at least 6 in the average room, and that's a lot of reflected sound. But why is reflected sound bad? I'll demonstrate using these two identical patterns. The blue pattern represents direct sound waves, and the red pattern represents reflected sound waves. They start out together, but when I move the red one backwards, like a delayed sound reflection, it creates destructive interference patterns which changes the original sound wave. Here's the problem. Original sound waves are distorted by strong, later arriving reflections. Also, sound travels really fast, about 1130 feet per second. A sound wave will bounce back and forth between these two walls about 60 times in 1 second. Sound travels so fast, it fills a room almost instantly. And this is only one bounce angle. Every room has thousands. How can we make our rooms sound better? Remember our Nerf guns? I'll shoot these at the same time, again representing a sound wave bouncing off a wall. Both discs bounce together in the same direction, which means the reflected sound is at full strength. Now let's use the first of our two acoustical tools, an absorber, to reduce the strength of sound bounces. To a sound wave, an absorber looks a little like a hole in the wall, so some of the energy doesn't come back. An absorber works by reducing the strength of reflected sound that would otherwise cause more destructive interference. But if we use only absorbers in a room, it makes it sound dull and unnatural. Historically, humans don't like overly absorbent rooms. So, let's use the second of our two acoustical tools, the curved surface diffuser. It also reduces the strength of sound bounces. A diffuser works by scattering the sound reflections in different directions, smoothing out destructive interferences throughout the room. Room acoustics are greatly improved using a combination of absorption and diffusion. It's all about reducing those flat surface reflections. Use a combination of absorbers and diffusers, and your room will sound a lot more natural. Thanks for watching.